45톤이 나온다. 그렇지?
그만큼 하면 이제 추방하면은 그 높이만큼 추방되는 양이 들어.
그치, 양이 45톤이 출강된다는 거고, 그 다음에 일정 시간, 2.6시간 후에는 다시 또 이렇게 쌓일 거 아니야. 그 사이에 또 태핑하고 그런 게 있는 거예요. 그래서 이제 아까 많이 높여놓은 거는 뭔가 하면 메탈 레벨에서 슬라그 레벨인데, 아까 메탈 레벨을 메탈 얼라우드를 그러니까 하면은 2m를 만들었잖아.
네.
왜냐면 슬라그 레벨까지는 올라갈 필요가 없고 이전 선까지 하니까 전체량도 할 수 있지. 슬라그 레벨까지 쭉 올라갔을 때 슬라그 레벨까지 메탈량이 올라가면은 5m까지 한 2m까지 올라가면은 슬라그도 그만큼이 또 더 생기잖아.
그렇죠. 네.
그러면은 이 오버가 될 거 아니야. 거기 원료도 있고 오버되니까 그런 거를 검증할 수 있는 기준이 되는데, 여기서 이제 입력해갖고 어느 높이는 얼만큼이랑 그리고 그 높이에 대해서 그 높이를 계산해 보면 요게 이제 처음에 만약에 이제 100kg를 딱 넣었는데 메탈이 얼마 슬라그 얼마 생겼잖아. 그 위의 높이, 그 위의 높이까지 하고 계산해서 태핑 주기라든지 핸들링 타임을 태핑 핸들링 타임으로 계산하고 있습니다.
Look, there is one explanation already, and this is very important. The metal is tapped at 1500, and the slag at 1600. And that's... Look, that's high, high temperature. So if I put... okay, here we... here, because you know, I had to change the formula for the because here you have sensible heat, you have the metal, and you have the slags. Yeah. And in one case you should put not the same. It's possible. It's very simple. But let's put here the temperature of the slag. Okay? Yeah. Because you know there is much more slag than metal. The slag has more importance. So look, it's much more. That's a strong explanation. And if you have slag at 1600 degrees, at this, and this is the origin of the highest losses, then my guess would be here about 10,000. And you see, then we are close. You understand? That's
and it's a bad case.
That's the explanation. But I cannot understand why they tap at such a high temperature. Because in Europe, it's not the case.
Temperature of
I explained to you that between the slag and the metal there is 50 to 100 degree difference. But normally I put here the temperature of the slag because metal is less important. But as I told you, in this formula it's easy to change to say that metal is 100 degrees less. We could make minus 100. You understand? This can be done easily. But the important fact is that they tap the slag at 1600 degrees and not 1400 degrees. No, we are close to their real consumption.
수수들이 이쁘게 좀 하나 만들어야 돼. 둘이 저 고기사 주관해갖고.
But you see,
응기사가 만들어놨다.
when you design a furnace,
Yes.
you will ask the customer at what temperature you want to tap. He will tell you. If he asks to tap at 1600, okay, you will not decide. He will decide. And then you put 1600 in the calculation. And then this requires a very high power. Okay. In case, of course, if the furnace is that large, I can understand that the bus resistance is higher. But 10 million, I've never seen. Okay, maybe maybe it is due to their I have to check. Maybe they need to tap at higher temperature because this slag. This slag, is only melting at higher temperature. So maybe they have a good reason. But okay. Okay. And the furnace of Gwangyang was built by Hatch.
Yeah.
I have seen from the design. But it's an old design.
No. 저 위에 거 계산해낼 수 있나? 그 위에 히트로스 되는 거.
저거를 하려면은
So heat loss, you can calculate, but need a bit time. Huh? But it will be high due to 800 degrees.
좀
You understand? If you have these heat losses,
저 중간에 그 중간처럼 히트로스 슬라브 층.
the problem is these heat losses.
Yeah.
Okay, this is normal for 1400 degrees. Huh? For 1600 degrees, I would expect higher. And so this would be higher also. And maybe much higher, because here you have depending on the type of cooling also. And then you have to make the addition with the heat losses on the top now. So it will be more than 10 megawatt.
So in that case, we calculate the heat loss from the burdens.
Later on, I mean, next time, I will give you some formula to calculate here, depending on the cooling mode, and to calculate here. Huh? But these I have to prepare.
그거만 하면은 니 체크하는 거 다 했어?
체크한 거야. 질문.
차.
이런 건 굳이 뭐 그냥
민간에
차 or
같은
코크니까
거는
예. 코크랑 비슷하게 보면 될 것 같고. 예. When I have a question, when we calculating ferromangan calculation, can you see the cell Q19?
In ferromangan calculation. In the other. Here?
Yeah, here Q19. Q19, and we consider this. If we calculate this one, we consider about the MnO2, not MnO.
No.
The reason is
Because in the ore there is we have the yes, the reason is that you never have or my recommendation is that you never have MnO in the slag. So you have MnO2, and this one is just this is MnO2. Now, what is your question about? Because we consider that we have only MnO2 in the ore. Yeah.
So this is analysis for ore, so we only consider MnO2,
Yeah.
not MnO.
Yeah.
Okay. I think so, but I will check about it.
Here again, of course, if you have a very special case where the MnO would be preheated, it could change. Huh? You agree?
Yeah.
If you make a calcination with carbon then you have no more MnO2. Huh?
In that case, some MnO can be.
In this case, you have 0 here and you have something there.
Okay, if the condition is different,
Yeah,
this one could be calculated.
yeah.
Finish?
Yes, I think so. What do you think?
It's the remaining some items, or when we studied your calculation,
No, yes.
And then exchange the email.
Yes, there are some. I said that I shall for next time.
Mm.
I shall prepare an estimate of the heat losses.
Mm. And as I know, when SNNC has a two function for treat the ferronickel. The one is they used big column without arc. And
Yes,
one
yes.
second is
Yes.
it has the arc. It's high voltages.
Yes, I have seen that
yeah.
they have very low specific.
Yeah.
They are 150 or so kilowatt per square meter. This is very low, and that is the reason.
They have two functions
Yes.
in the same year.
Yes,
SAF.
exactly, exactly. But you were not there before, but we have clarified the problem of yield.
Yield. Yeah.
Did somebody explain to you?
Yield?
The yield, you were surprised
Mm.
that the yield can be 45 or 60,
Yeah.
or you told me, but you have to tell us what is the yield. No, I cannot tell you, because the customer will tell you that he wants more than...
Yeah. In case of the nickel, it's okay. In case of SNNC, at first, the nickel yielded 18%, and now it's 21%.
Exactly,
of
and
nickel.
then they must increase
Yeah.
they must to increase the nickel concentration.
Mm.
They must decrease the iron in slag.
Yeah, I mean, what I said is its values reduction yield. For example, this mangan and Fe and molybdenum. This yield we don't know. Man.
Okay,
So
but
the customer or the owner of the plant, they did not know its contents the yield reduction. Reduction yield. They know only the ferronickel yield or mangan yield. In case of the high metal, they are concentrated just the reduction of the manganese.
Yes, but I told also for manganese,
Mm.
they don't know the yield. They want to have, in case of manganese, about 30% manganese in the slag, because they have two products to sell. And so they will adjust the carbon to have the good yield of manganese. And here it's the same. Here they adjust the carbon to have the good yield of Fe, of iron. The other yield are not so important. The other yield are really not important. You see, if we have here 30% instead of 15, we change 0.1 to 0.2. This you can forget this.
You mean CO? Carbon?
No, chromium.
Mangan.
Chromium.
No, I mean what is important?
The-
Nickel, mangan.
No, here of course you must have a good nickel yield, and here you must have at least 95%. you can be sure at least 95%. And the other, the adjustment parameter is the yield of iron. And the yield of iron, it can be 40 or it can be 60. You just, what you must check is the result that you have. Sorry, no, it was the wrong way. Is the result in nickel. You see, if I put 40, we have 20% nickel. If I put 60, we will have
More.
17. No, less.
Less.
Because if you increase the iron, you dilute the nickel.
We adjust the reduction yield, and we match the nickel.
Exactly.
Okay, I see.
And in practice, of course, people, the operators do not adjust the yield, but they adjust the carbon. Huh? And if we change the yield here, you see, if I put 60, you increase the carbon. And this is what they adjust, the operators. But you see, if I increase the iron yield, no, I have more iron and I have less nickel.
But please upload up. The 1, 2, 3 lines. Okay. No, okay. If we change the coke,
Yeah.
we input charge the more coke, you can
Yeah.
change the nickel.
Yes. Yes, but this is not calculated here. This is given as an provisional material, typical.
I mean, when we do the new project,
Yes.
and we calculate the coke,
You calculate the cost.
dolomite,
Yeah.
and so on. Yeah.
Yeah.
But we have two variables. One is reduction yield. One
Yes.
is the charging the coke and dolomite.
No. When you calculate the coke. You will calculate the coke. And of course, after to design the installation, you must put a margin. You must say coke can be more sometimes.
Okay.
But if you, what the customer says to you, it says to you, I want a metal with 20% nickel at least, or 22. Sometimes it is, and the coke you calculate, or maybe he gives something typical, but the coke.
This is coke.
No. This
FE.
is the FE yield.
FE yield. Okay.
You see, to have 20% nickel.
You mean the FE and the nickel? Okay. And I think it is better to discuss after we studied this.
Okay.
Your calculations.
Okay.
It is better, and
Okay.
we understand more.
I understand.
And then we discuss one more
Understand.
time.
No, it was just to explain a bit.
Yeah.
You must study, of course.
그럼 다 됐으면 저거 하지. 그러니까 수정한 거하고 언제 줄 건지 그런 거하고 좀 적어놓고. 그다음에 저쪽 거는 데이터에 끝나가지고 그대로 하면 된다 이거지. 그지?
뭐요?
그 저기 이제까지 하는 거는.
저까지 하는 거는
Maybe in the end of this year or the January or the next year, and you come Korea one more time, and for the supervision of the pilot plant. At that time, we have one more chance to discuss it.
Yeah.
And during after we studied and we make it some our the manuals.
Yeah.
And then we will ask you.
Okay.
다 됐나 여러분? What is your flight schedule?
5:30 or
You said
5:50.
5:50. 그럼 지금 몇 시지?
2시 반이네요.
시간 좀 많이 남았네. 그럼 어떡할까? 또 다른 거 더 물어볼 거 있나? 공사. 좀 더 공부를 하고 물어보면 좀